Good day, everyone. I am Don Liz Marie Alcejo, and my report is all about speed measurement. So, for the objectives, after the discussion, students will be able to know the history of speed measurement, know what is the meaning of speed, linear and angular measurement, know what are the things to use in speed measurement, identify the formula of linear speed measurement, identify the formula also of angular speed measurement, and to know how to solve speed, linear, and angular measurement. So, the history of speed measurement. So, the Italian physicist Galileo Galilei was among the first to try to measure the speed of light. In the early 17th century, he devised an experiment in which two people with covered lanterns stood a known distance apart. One person uncovered his lantern, and as soon as the other person saw the light, he uncovered his own lantern. Galileo attempted to record the time between lantern signals, but was unsuccessful because the distance involved was too small and light simply moved too fast to be measured this way. The first known measurement of speed was done by the great Italian physicist known as Galileo Galilei. He recorded the distance traveled by a body and the time it takes to do so. According to Galileo, speed can be defined as distance traveled per unit of time. The formula according to Galileo is V is equal to d divided by t, where v is used to denote the speed of an object, and on the other hand, t and t are used to distance traveled and time consumed, respectively. So, for example, speed of a bike is 30 kilometers per hour. So this means that the bike travels 30 kilometers in an hour, and that is the speed of the bike. So now, let's proceed to what is speed measurement. So speed measurement is the process of determining the rate at which an object is moving. So speed measurement is important in many fields including transportation, sports, and law enforcement. It is typically measured in units such as miles per hour, kilometers per hour, or meters per second. Speed tells us how fast something or someone is traveling. You can find the average speed of an object if you know the distance traveled and the time it took. Speed measurement is vital in transportation where it is used to monitor the speed of vehicles, aircraft, and ships. It is essential for safety and traffic management as well as for monitoring fuel consumption and emissions. In manufacturing, speed measurement is used to monitor the performance of machinery and equipment, detect defects and irregularities, and optimize production processes. In sports, speed measurement is used to evaluate the performance of athletes and determine the winners of competitions. It is commonly used in track and field, cycling, and motorsports where athletes and vehicles are timed to determine their speed and performance. So there are types of speed. The first one is uniform speed. An object A object is said to be in uniform speed when the object covers equal distance in equal time intervals. So if an object covers an equal distance in an equal interval of time, so it is moving with a uniform speed. The second one is the variable speed. So a object is said to be in variable speed when the object covers a different distance at equal intervals of times. So if the speed of a body is changing with respect to the time it is moving with variable speed, it is also known as non-uniform speed. The third one is the average speed. Average speed is defined as the uniform speed which is given by the ratio of total distance traveled by an object to the total time taken by the object. So average speed is calculated by dividing the total distance that something has traveled by the total amount of time it took it to travel that distance. And the fourth one is instantaneous speed. When an object is moving with variable speed, then the speed of that object at any instant of time is known as instantaneous speed. So the instantaneous speed is the speed of an object at a particular moment or instant in time. So the methods of speed measurement. So there are several methods for measuring speed, including radar, laser, GPS, and timing devices. Radar and laser speed guns are commonly used by law enforcement to measure the speed of vehicles. GPS technology can also be used to determine the speed of vehicles and other moving objects. And timing devices such as stopwatches and speed cameras are also used to measure speed. There are also types of speed measuring devices. The first one is the speedometer to measure car speed. Speedometer is the most bolded instrument panel that we easily notice on the dashboard in a car. So this measuring tool is installed directly in the system. It gives a real-time reading of the car's speed. So the same thing happens to other transportation as well as such as the bus, the trucks, the bike, or the motorcycle. The second one is the radar. Radar empowers the use of radio waves to measure the speed of a moving object. It does not only calculate speed or the velocity, but also the range and angle. This instrument is so common in aircraft and ships. So this device will allow you to measure the speed of a car although you don't drive it. Another benefit is to measure the run speed of a footballer. So there are lots of benefits in the field of sport also. The third one is the LiDAR. LiDAR stands for light detection and ranging. So this device utilizes 600 to 1000 millimeters laser light, measuring the distance via the reflecting time of the laser that reverses back to the receiver. So more advanced LiDAR device involves GPS to create a more comprehensive visual result. Fourth one is anemometer to measure wind speed. So the next speed measuring tool that we have on the list is an anemometer. This is the device that is generally found in a weather station. It functions to measure the wind speed along with the wind direction. So also an anemometer is used in many areas such as HVAC, storm chasing, kite surfing, and drone. The fifth one is the ranger finder. A range finder is like a binocular, but it's able to read the distance between the device and the object being watched. It's not weird that an advanced range finder comes with a speed meter feature. So Finder allows you to observe also a moving object while it's displaying the object's speed. So the formula of speed measurement is equal to speed is equal to distance divided by time, where speed is the rate at which an object is moving. Distance is the length of the path covered by the object, and time is the duration of the movement. So the formula speed is equal to distance divided by time can be rearranged just like any other equation. The formula can be rearranged in three ways. First one is speed equals distance divided by time. Second one is distance equals speed times time. And the third one is time equals distance divided by speed. So for example, the given distance here is 100 meters and the given time is 10 seconds in the first illustration. So using the formula, 100 meters divided by 10 seconds is equal to 10 meters per second. So here in the second illustration, the given distance is 1000 meter and the given time is 2.89 seconds. So using the formula, 1000 meter divided by 2.89 seconds is equal to 346 meter per second. Another example is a car travels a distance of 120 kilometers in 2 hours. What is the speed of the car? So using the formula speed is equal to distance divided by time, the given distance here is 120 kilometers and the given time here is the 2 hours. So 120 kilometers divided by 2 hours is equal to 60 kilometers per hour. Therefore, the speed of the car is 60 kilometers per hour. Another is a person runs a distance of 400 meters in 50 seconds. What is the speed of the person? So the given distance here is 400 meters and the given time is 50 seconds. So 400 meters divided by 50 seconds is equal to 8 meters per second. Therefore, the speed of the person is 8 meters per second. So let's try. A cyclist covers a distance of 15 kilometers in 2 hours. What is the speed of the cyclist? So the given distance here is 15 kilometers and the time is 2 hours. So 15 kilometers divided by 5 hours is equal to 3 kilometers per hour. Therefore, the speed of the cyclist is 3 kilometers per hour. So let's proceed to the two types of speed measurement. These are the linear and angular speed measurement. First, let's have linear speed measurement. Linear speed is the measure of the concrete distance traveled by a moving object. So linear speed is typically measured in units such as meter per second, feet per second, or kilometers per hour. These units are used to express the rate at which an object is moving in a straight line in relative to a fixed point. Methods of linear speed measurement. There are several methods for measuring linear speed, including using a speedometer, tachometer, or encoder. A speedometer is commonly used in vehicles to measure the speed of the wheels. A tachometer is used to measure the rotational speed of a motor or engine. An encoder is used to measure the linear speed of speed object by detecting changes in position. So the formula of linear speed measurement is equal to V equals S divided by time, where S is the distance traveled and T is the time taken. Also, linear speed measurement in the sense of angular speed is articulated as V equals W times R, where V is linear speed or the meters per second, W is angular speed or the radian spheres, and R is equal to radius of the circular path. So for example, a car travels at a constant speed around a circular track with circumference of 3 miles. If the car records a time of 12 minutes for 7 laps, what is the linear speed in miles per hour? So the given time here is 12 minutes or 1/5 hour, and the 7 laps and the 3 miles. So we should multiply the laps and the miles. So 7 times 3 is equal to 21. And instead of using 12 minutes or 1/5, we should use the zero point 0.2. So using the formula, V is equal to S divided by time. So 21 divided by zero point 0.2, and the answer is 105 meter per hour. So the next one is the angular speed measurement. Angular speed is defined as the rate of change of angular displacement, and it is expressed as follows. So angular is equal to central angle divided by time, or where it is in the angular displacement and the time in the angular speed. So angular speed unit. So the unit of angular speed is the radian per second or revolution per minute. These units are used to express the rate at which an object is rotating or spinning around a fixed axis. So the angular velocity is a vector quantity that expresses both direction and magnitude, while angular speed describes the magnitude only. So the methods of angular speed measurement. There are several methods for measuring angular speed, including using a tachometer that is commonly used to measure the rotational speed of a motor or engine, and an encoder is used to measure the angular speed of an object by detecting changes in position. So the formula of angular speed measurement, where W is angular speed measured in radians per second. So, and the central angle that the object turns through, and time period of one rotation. So revolutions per minute, or abbreviated RPM, revolution per or divided by minute, revolution divided by minute, or revolution times minute minus 1 is a unit of uh, rotational speed or rotational frequency for rotating machines. So the formula for this is RPM is equal to revolutions divided by minutes. For example, so let's solve an example with an angular velocity is 40. So find the number of revolutions per minute. So this implies that the given angular velocity there is 40. So with the formula 60 divided by the formula 2 pi, so 40 times 60 divided by 6.284. So 40 times 60 is equal to 2,400. So 2,400 divided by 6.284 is equal to 381.9. Therefore, the number of revolutions per minute is 381.9 minutes. Another example is our Earth takes about 365.25 days to finish one revolution around the Sun. So converting days into seconds, we get time is equal to 365.25 times 24 times 60 times 60 is equal to 315,500, I know, 31,557,600 seconds. So we know that angular speed is equal to 2 pi divided by t, Hence, angular speed is equal to 1.99 times 10 minus 7 radians per seconds. So therefore, the angular speed of Earth is 1.99 times 10 minus 7 radians per seconds. So these are the things to use in speed measurement usually. The first one is a revolution counter and timer. So a revolution counter and timer is an electronic device that is used to measure the number of revolutions or cycles of a rotating object and also the time it takes to complete one revolution or cycle. The primary objective of a revolution counter and timer is accurately measure the rotational speed of a machine or equipment, which is essential in determining its efficiency and performance. So the revolution counter and timer works by using sensors such as percec- proximity sensors or a photoelectric sensors to detect the rotation of the object being measured. So the sensors send a signal to the device which calculates siya sa number of rotation and a time taken for each rotation. So revolution counter and timer consist of a worm and a worm gear or a wheel in mesh. The shaft whose speed is to be measured is connected to worm when the rotating shaft is engaged. Hence, it drives or rotates the worm, gear, or wheel in mesh. So arrangement is made in such way that one revolution of worm causes the worm gear to rotate by one tooth. This arrangement employs a timing device which counts the number of revolutions measured during certain time interval. So a pointer is attached to worm gear. So working of revolution counter and timer. When rotating shaft drives the worm gear starts to rotate. Rotation of the worm gear actuates the pointer and makes it to move over calibrated dial or which is the scale. So this movement of pointer can be directly calibrated to give number of revolutions made by the shaft within a specified time. Thus, the revolution counter and timer gives the total number of revolutions over a given time, average rotational speed, rather than an instantaneous rotational speed. So, there are advantages of revolution counter and timer. These are the simple to operate, simple in construction, also mostly used to measure speed of shaft, pulley, gear, and etc. Also, there are disadvantages of revolution counter and timer. These are it is limited to low speed measurements, more chances of error, and it gives average speed instead of instantaneous speed. So the application of revolution center and timer. So it can be used in a variety of settings, including manufacturing, engineering, and research. This type of application will allow users to accurately measure the number of revolutions or cycles of a machine or device, as well as track the time it takes to complete those cycles. So the application would include features such as a user-friendly interface that allows users to easily input the number of revolutions or cycles they want to measure. Real-time tracking of revolutions and time with the ability to pause and resume as needed. Customizable settings for different machines or devices, including units of measurement and cycle duration. Ability to export data to a spreadsheet or other document for analysis and reporting. Integration with other tools and equipment such as sensors or controllers for more advanced monitoring and control. So the next one is the tachometer. Tachometer is used to take speed measurements in hard to reach and remote locations to ensure your equipment is operating up to specification. So tachometer is a sensor and measuring device that can measure the revolution speed of the rotating objects. Can measure the revolutions per minute of dangerous moving machinery at the safe distance. For for monitoring your machinery and troubleshooting performance. So there are types of tachometer. So the types of tachometers commonly found are mentioned below. The first one is the analog tachometers. So comprise a needle and dial type of interface. They do not have provision for storage of readings and cannot compute details such as average and deviation. So here, um, speed is converted to voltage via use of an external frequency to voltage converter. So this voltage is displayed by an analog voltmeter. So the second one is the digital tachometers. Comprise LCD or lead readout and a memory for storage. These can perform statistical operations and are very suitable for precision measurement and monitoring of any kind of excuse me, time-based quantities. So the next one is contact and non-contact tachometers. The contact type is in contact with a rotating shaft. The non-contact type is ideal for applications that are mobile and uses a laser or optical encoder or magnetic sensor is used. Meron siya example. So the next one is the time and frequency measuring tachometers. So both these are based on measurement methods. The time measurement device calculates speed by measuring the time interval between the incoming pulses, whereas the frequency measurement device calculates speed by measuring the frequency of the incoming pulses. So let's proceed to the application of tachometer. So as we mentioned before, tachometer is used for measuring the rotating speed of the rotating objects, and for that reason this device is used in motor vehicles. Namely, the tachometer is used in marine fleet for measuring the rotating speed of the marine diesel machines on the board ships. This device shows the direction towards which the ship rotates. But the use of this measuring device is much broader. The next one is broad range of vehicles such as automobiles, tractors, trucks, airplanes, trains, and other light rail vehicles. So also in medicine, the device known as HEMA tachometer that is used for estimating the blood flow rate, and many laser instruments and devices. So the next one is the stroboscope. So the next one is a stroboscope. A stroboscope, also known as a strobe, is an instrument used to make a cyclically moving object appear to be slow moving or stationary. So the principle is used for the study of rotating, reciprocating, oscillating, or vibrating objects. So machine parts and vibrating strings are the common examples. So, a stroboscope is an electronic device used to create a flashing light that can be synchronized with the frequency of a rotating or oscillating object. So, the flashing light, a stroboscope, makes the object appear to be stationary or moving in slow motion, allowing for precise observation and measurement of its motion. So the primary objective of a stroboscope is to provide a visual tool for analyzing the motion of machinery and other objects. So the stroboscope is commonly used in manufacturing, automotive, aviation industries for inspecting and maintaining machinery. So stroboscope come in various types including handheld, portable, and stationary models. Handheld stroboscope are compact and easy to use, making them ideal for fieldwork and on-site inspections. Portable stroboscopes are larger and more powerful, suitable for use in a laboratory or workshop. Stationary stroboscopes are fixed in place and used for continuous monitoring of machinery. So, it is also used to measure an angular speed between 600 to 20,000 revolution per minute. It is the method measured by adjusting the receptor frequency, a device used to analyze the motion of a moving object to determine the RPM or linear speed of a moving object using high speed flashes of light. So the history of stroboscope. Joseph Plateau of Belgium is generally credited with the invention of the stroboscope in 1832, when he used a disc with radial slits which he turned while viewing images on a separate rotating wheel. So Plateau called his device the Henakistoscope. So there was a simultaneous and independent invention of the device by the Austrian Simon von Stampfer, which he named the stroboscope, and it is his term which is used today. The etymology is from the Greek words strobos meaning whirling, and the scope meaning to look at. So the applications of stroboscope. First one is electrical industry. Observation of moving shafts, axles, driving elements, rotors, driving gear, clutches, belts, bearing, pinions, etc. Slip measurements between two shafts early determination of stresses due to vibrations, testing of material, calibration of engine tachometers, counters, amplitude measurement. The next one is automobile and engine industries. Testing of valves, valve teeth and springs, valve rocker arms, full spray studies of petrol fuel injection equipment, inspection of nozzles for proper operation, observation of belts, propellers, vents, gear driving, vibrations, springs, generations. The second one is the chemical industry. So study and inspection of mixers, dosing machines, pumps, conveyor belts, stirring apparatus, packing machines, tablet punching and stamping machines, separators, centrifuges, air pressure transport system, filters, propellers, swimming sieves, mancing, grinder, and crushing machines. Next one is optical industry. So testing of a camera shutter, calibration of camera shutter speed, control of film transport, checking of film cameras and projectors as well as parts thereof like ventilating systems, vents, driving belts, analysis of lenses, grinders, cutters and other machinery, taking photos for motion studies under stroboscope, flashlight. So the last one is the shipbuilding and aircraft industry. So cavitation studies of air pockets against the blades of turbines and propellers, checking all motions of ship engines, generators, ventilation systems, testing of aircraft engines and propeller blades. So that's all my report. Thank you for listening. God bless.